Today we are solving book match. In this question, we are given two arrays, collection A, collection B, each representing collection of books in a library. Collection A is of size n, collection B is of size m, and we need to find the number of sub-segments inside collection A of size n such that the elements inside that subsegment should also be present inside collection B, and the count of such elements inside that window should at least be k. What I mean by that is, if you look at this example, this is a collection A array of size 7 and this is collection B array of size 4. I need to find at least two elements inside one window to make it valid or to count it as valid. So the first window is this one of size 4. Inside this you can see all the elements or all four elements are part of collections B array, so this is a valid window. Then I'll move to this window. This is also valid since all the elements are part of collections B. In this window I have 2, 3 and 4 which are also present in collections VRA. So this is also valid since the count is 3 and minimum I require is 2. Then I'll move to this window. Here I have two elements 3 and 4 which are also a part of collections B. This is also valid, hence my answer will be 4. Now let us solve this problem. To solve this problem, we will use the sliding window approach. I have taken this example. Here k is equal to 2. And before we start this approach, we need to pre-compute the hash table for collections B so that we can validate whether an element is a part of collections B or not. And we will also need this hash table for the window. So all the elements present inside the window, we will keep it here and the frequencies. We'll take a window of size m, and for every element inside that window, we will check if it is a part of collections B or not using this hash table. If it is, then I'll increase the count by 1. And once I have processed all the elements inside the window, if the count is greater than or equal to k, then only I'll increase the answer by 1 because that window was valid. So we'll increase the answer by 1 and then we'll move the window to the next element. Let's start with the example. So we'll process 1 here in the window. I'll increase the frequency, and since it's also part of the collections B array, so I'll increase the count. Now I have 2. I'll increase the frequency, and it is also present in the collections B array, so I'll increase the count again. Again I have 2. I'll increase the frequency, but this time I only have a maximum of 1, 2, right? So I don't need that extra 2 that is present in this window, so I won't be changing anything. Now we have processed all the elements. So and after this processing, we found out that the count of such element inside that window was 2. One was the number 1 and the other one was number 2. So these are the elements that are also present in collection speed. And since this value of count is equal to k, that means that this window is valid. So we'll increase answer by 1. Now we'll move the window. But before doing this, we need to also check, since this 1 was part of this count, but now it's not a part of the window, so we need to take care of this as well. So decrease the frequency and decrease the count as well. Okay, now I have 1, 2 again, so change this to 3. Yet again I have only a maximum of 2, 1 here, maximum of 1, 2 here, so I won't be changing the value of count. So I have processed all the elements. Now we'll move the window to the next element, but I need to reduce the frequency, right? So Okay, now I have 4, but 4 is not present in the collections BRA, so I won't be changing anything here. Now we'll move the window again, reduce the frequency of 2, and then I have 5, right? 5 is present inside the collections BRA, as you can see. So I will increase the count to 2. And we have processed all the elements, and also the count is equal to k, so we'll increase the answer by 2 to 2. Yeah, so this is how we'll approach, this is how the approach will work. If you keep moving this, we won't be finding any element any window that satisfies this condition. So the answer will be 2 here. Now let's look at the code. This is the C++ solution. We are using the unordered map to store the collections BRA and the frequency, the left right pointers for the sliding window for the window, and this map frequency A for storing the elements of the window. This loop is used to initialize the window of size m, and inside this we're increasing the frequency of all the elements encountered in the window, and then we are checking if the frequency encountered till now inside the window is less than or equal to the frequency of that element present in the collections BRA. This is done because if you remember, in this case we had 3 twos, right? And we needed up to maximum of 1 2. So to prevent this case, uh, we've written this code, right? And then we are just handling the window inside this main loop. We are just moving the left right pointers and taking care of the elements that have left the window. So we are decreasing the frequency, and if that element that left the window had was a valid a part of the count, right? So if the element that left the window had a frequency less than or equal to the frequency of that element present in collection speed, then only will it decrease the count. And then we just move with the left right pointers and then updating the answer. This was the code. Thank you very much.